It's about to start, we'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound, check. Camera, check. Lights, check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is really exciting stuff. We are going to start a feature on our Automixer that will integrate the Automixer with video stuff, which I think is probably one of the few I think it's the only Automixer that will be able to do this. So it's really exciting that we are adding this feature today. But first, let's do a recap. And even before I do a recap, hello, Tail. Great to see you here. Thanks for joining us. So first, a recap. If you are new here, we have been doing audio effects in REAPER, so real-time audio processors using the JSFX language. And we are doing a library that will help other developers develop their audio effects, and we are also using the library in a couple effects. And right now we are working on this effect that is called an Automixer. The purpose is that if you have an interview or a roundtable or something like that, where there are multiple microphones for multiple people in the same room, an Automixer will adjust the gain of the different microphones according to who's speaking. So it will prevent some of, or maybe even completely eliminate, the issue of one person speaking and their voice being picked up by many microphones, resulting in this kind of reverb that you don't want in a conversation. Anyway, let's dive into the code, and I will show you the specifics of what we need. Let's drop a couple of Automixers in a couple of tracks here. No, not this one. This is the old version, the development version. So this is the one that I'm talking about. And as usual, I will do my setup where I have my microphone in one track and a tone generator in another track. Just like that. So as you can see, the Automixer is already in action. The red is the gain that was allocated to my microphone. And you can see that the gain allocated to my microphone goes up when I'm speaking and goes down when I'm not speaking, to make space for the supposed other person who is speaking. And I guess in this case, the other person is the tone generator. So anyway, we want to add this feature that can be, first of all, used for post-processing. So when you are editing an interview, pre-recorded material, post-production kind of thing. So we'll first look into that. But we will also try to extend this to use OBS, to integrate with OBS and allow you to do this kind of auto-mixing on the fly in real time. And well, what does it mean to do auto-mixing of video? Well, it means that the person who is speaking, so suppose you have multiple microphones in a round table, multiple cameras in a round table, one camera per person. So the person who is speaking will be the scene that is selected, will be the camera that will be showing in the video. And then someone else starts speaking, the scene cuts to them. It changes cameras based on who is speaking. So you can do this in a live situation even, and you would have a very fancy editing kind of thing for a kind of broadcast, all done automatically using the Automixer. So it is similar in spirit to what happens in like a Zoom call and maybe in other chat apps as well. But Zoom is the one that comes to mind, where there is a view of every person, like a little box for every person in the conversation. And then there is this other view that is the person who is currently speaking. And it switches to different people. So it's like that, but for broadcasts using OBS and for post-production when you're editing a kind of video podcast or an interview, that sort of thing. So how does it work? Well, first we need to know who is the person that is speaking. And of course, we cannot really tell for sure. So we're going to just go by who is the person who has the most gain on their microphone. Naturally, if multiple people are speaking, then we will just have to select one of them. But the point is that we want these transitions to be as natural as possible. We don't want the cameras to flicker from one to the other very fast. So that will be the hardest part. So I guess there are 3 or 4 parts to the thing that we are doing. First, we have to find who is the person who is speaking, and that's just finding the gain that is the largest amongst all the tracks. Second, we need to smooth out this data so that we are not flickering between cameras too much, so that the transitions feel natural. Third, we need some way of communicating from the Automixer, who is doing all this detection, communicating that information to the outside world. That means to a video processor if you're doing post-production. So if you're doing video editing in REAPER, we need to communicate that information of who is speaking, what is the active camera. We need to communicate that to the video processors. And if you are doing a live broadcast using OBS, we need to communicate that information to OBS so that it can switch scenes. And Tarmi is here. Hello. Yes, it is hot in most places. But hello, it's great to see you here. Has been a while. Okay, in today's stream, let's narrow the scope. I don't think we'll be able to do all the 4 steps I mentioned. That's why the stream is called Starting the Automixer for Video and not just doing the whole thing. I think we will be able to find the loudest microphone, to find the person who has the most gain allocated to them. I think we'll be able to do this today. We'll see. But I wanted to paint the picture of the whole thing that we'll be doing. Well, one thing is for sure. We are implementing this Automixer in a way that you have multiple instances of the Automixer, one per microphone. And all these instances will need to communicate and collaborate because they need to find who is the loudest microphone, who is the microphone with the most gain allocated to them. So we currently have a way of letting the instances communicate between themselves. To even compute the gain in the first place, these red lines are computed in such a way that they add up to 1. So there is already some interplugging communication going on. We'll have to extend that to allow for this other part of the picture for computing who is the person with the most gain allocated to them. So we already have a way of communicating between instances. We just have to add one extra field there. And you may be thinking, well, why can't I just use the result of the computation of the red line in the first place? Because this red line was computed taking in account all the instances. Well, the problem is that there are some things that are taken in account when computing the red line that are beyond just looking at all the instances. So you do look at all instances to see how much signal is coming through every microphone in order to compute this red line in the first place, but then you do some extra stuff like I guess, the priority and even the strength. All of these are computed after the basic Automixer algorithm. So I think that the best course of action really is to allow every instance to broadcast to every other instance. This was the gain that I ended up computing for myself. And then if every instance does that, then the instance that has the most gain allocated to it will be able to say, okay, I am the winner for now. And I guess we will try to follow this rule that one instance that is the winner, so to speak, that is the person who is speaking, that will be the instance that will set the flag saying, okay, I am the winner now. So it is the winner who is responsible for updating that information. So we'll establish the protocol, because we have a problem of a distributed computation here, right? We have multiple instances of the plugin running, so we need to have some sort of reason here, some sort of order to the madness. And I guess the rule is going to be an instance will only be able to set itself as the winner. But in order to be able to set itself as the winner, it will have to, I guess, go through several challenges. The first of which is being the loudest microphone, but there will be more conditions so that we can smooth things out and make the transitions natural. Yes, but to keep it natural, it should also require that when the one person is speaking, the camera can switch to the one that is listening as well, to each to the person. The talking person isn't really good. To switch to the talking person isn't really good. How is it possible to manage this situation in Automix? Well, currently, I have two answers for this. The first is, if you switch to the person who is speaking and the person is just speaking for too long, we will have this notion. We currently don't. Not in this version of the Automixer. We have implemented this in a previous stream in the previous version of the Automixer. And we will implement it again. But the solution is, if the person is speaking for too long, we cut after some given time to a wide view camera, if such a thing even exists in that kind of setup, right? We are imagining here that would be one camera per person and then one extra camera with a wide angle that will show everyone in the conversation, including the person or the people who are listening, so you can see their reactions. So that's one part of the answer. You have this, I guess, escape hatch. If one person is speaking for too long, you cut to the wide angle. The second answer, well, and I guess this is the best we can do automatically, right? Because we don't really know who is listening. If there are only two cameras, then maybe you could say that just cut to the other camera to see the other person's reaction. But if there are many cameras, then do you just switch to a random one? Maybe. We would have to think about what exactly we want to do. And I guess the best way of going about this is listening to the feedback of people actually using the Automixer. I have been in contact with Riley from Podigy that does podcast editing, and his use case was this that I mentioned, the wide angle kind of thing. And yeah, in case of many cameras, you could go to a random one, but it also feels a bit weird that you may be cutting to a camera that there is nothing happening. So the person is not even reacting. So you would be cutting to a random person. Kind of weird. Maybe that will come in handy to someone and we will implement it. But to begin with, I will do the wide angle thing. And I guess the second answer I have to this is that we cannot automate this because there are some things that just require a human looking at all the cameras and saying, okay, I'm going to stop the Automixer for a moment and switch to this person. They are not speaking, so the Automixer didn't pick them up, but they are doing something interesting. They're doing a facial expression or some kind of reaction that we want to capture, so cut to them. And of course, you can do that with OBS very easily. And if you're doing post-production using the video processors in REAPER, then people can use my solution for multicam editing. So one of the multicams can be the result of the Automixer. So you can, while editing in REAPER, you may have the Automixer be in charge of doing the cuts for a while, and then at some point you may use this script that I developed to intervene and say, okay, cut to camera 3, then okay, cut back to the Automixer, and that sort of thing. So we can come up with some heuristics as to what would work, like cutting to a random camera, cutting to the wide angle, and we can empower people who are in charge of the broadcast to switch in and out of the Automixer as they see fit. All right. And Siwitz is here. Hello, Siwitz. And you ask me how it's going with the Automixer. It is going well. The C++ part of things we will talk about tomorrow, but spoiler, there isn't much. I haven't really worked on that front that much. But I have been working on the Automixer a whole lot, and it is pretty functional. There are still many glitches, and I am starting to work on one of the most exciting features for me. That's the video extension that, as far as I can tell, there is no other tool that does something like this. Okay, sure, in post you can, but when you are live, perhaps you can also randomly switch the cameras to with some random delay. We can. Sure. It results more natural than just cut in the moment in which each speaker is talking. Yeah, so we will start today with this notion of finding the person who is speaking, because that's essential to do an effective automixing. But that's not the really interesting and deep part of this. The interesting and deep part is, first of all, try to make the cuts look natural. So if you were just simply trying to follow the person who is speaking, try to make that in a natural manner. So if someone just is randomly in the middle of someone's sentence, another person may say something like, uh-huh, you know what I mean? So someone is talking, and when they take a brief pause, someone says, uh-huh, and then the person continues speaking. You may or may not want to switch to the other person who says, uh-huh. Just because they were the loudest person for a moment doesn't mean that you want to cut to them. So we will have some heuristics, some sliders that will set some kinds of timeouts to make this as natural as possible so it doesn't flicker and it doesn't feel weird. So that's the initial step. And then we'll get into these heuristics. What will make this more like a human was editing this? What would a human do? Is this something that we can emulate? And of course, something like looking at the reactions of someone and cutting to them, that's beyond this scope because it involves facial recognition and whatnot. But to the extent that it is feasible, we will try to make it human-like. Yeah. And I guess for a broadcast, it will work relatively well because if you're editing in post-production, then yeah, you can see someone's reaction, go back, cut to them before they react so that you can show the reaction. But if you're on a live setting, maybe you are doing a broadcast with a delay so you can capture these kinds of things. But I think that in most cases, you don't, right? You don't always catch the reactions because they happened and you didn't cut before they would happen. So with unscripted kind of broadcast, it's just the nature of the game. Anyway, let's dive into the problem that we are going to start with, the problem of finding the loudest microphone. And I guess, again, the simplest thing we could do is just look at the microphone that is, I was going to say, look at the microphone that is above 0.5, right? Because if they add up to 1, then the microphone that is above 0.5 is the loudest. And if there are 3 microphones, look at the microphone that is above 0.3. That is not really how I think this should be done. So instead, let's use that channel of communication between plugin instances to allow the instances to collaborate and see each other's gains that were allocated. The gains are the little red lines here. See each other's gains and determine who is the winner and set that as just a variable somewhere that we will communicate with this outside world, video processors and OBS somehow. So there is this data structure here that is used for communication between plugin instances, and it is communicating the RMS, which is the, let's say, the loudness of the microphones. That's used to compute the red line, that is the gain. Let's add another field that is really the gain. And that will be field number 3, and now the data structure will have 4 fields total. And is this how I call things? I think I call it gain. Am I right? Yes, I am right. I call it gain. So yeah, that's the name of the field here on this data structure. So when we compute the gain, we use the gain to do the attenuation, but we also need to now add this gain to that, let's say, the bus that is being used to communicate between plugin instances. And I think I will go ahead now and take this measure of allowing you to turn off and on the Automixer for video features, because we only need to compute who is the winner, who is the loudest microphone, if you are doing the video stuff. And right now, it's going to amount to setting a global variable and reading as some global variables and doing just a little bit of computation. But I think that moving forward, there will be many computations that we need to do to determine the winner. And these will be potentially expensive in the sense that it will take a lot of CPU to do all this. And I may not want people who are not using the Automixer for video to pay this CPU price. So I'm sort of doing premature optimization. I know, but I have a good feeling. I have a good feeling. I think that it will pay off. So let's have a slider that I will call slider 5. So this will become slider 7. And this will be video. And by default, it will be off because I suppose that most people will not be using the Automixer for video. And then, oh, this is one of the settings that needs to be group synced. We talked about this a whole lot yesterday. But it is something that we need to sync across groups, because we do have this notion of groups. So you could have a group that is one room with 5 microphones over here, and then another group that is 3 more microphones in another room, and then the 2 rooms are connected via Skype, for instance. That kind of situation, and you would like the Automixers to work separately. So you have this notion of groups, and this parameter needs to be synced across the group because we want all the instances in the group to share the video setting. So that's what we are about to do now. I'm just going to look at these, and I'm going to replace that with that, and the default is 0, which is off. And I guess I will have an enumeration of the possibilities here. And I suppose I better put this there, like so. Okay. And then we also have this other data structure to allow different instances to communicate and share their group settings, so that when you change a group slider in one instance, it is reflected in all other instances. So now I'll have to also come here and add another field to this data structure as well, which now has 4 fields, 0, 2, 3. And then I'll just go through and find the places where I need to do work to sync these things up. I think I got all of them. No? I did not get all of them. I think I got all of them now. We'll see. You missed the start. Well, it's okay. If you have questions, then ask them on the chat, and I'm happy to repeat any explanation if you want to hear something specifically. Okay, did I get all of them? I don't know. Let's see. Instead of looking for look ahead, let's look for strength. I added some stuff here to the data structure, added something there, added here, added something here. Why is the group the last one? I think it is a leftover from when this slider was the last one, but now it is the first, so I think that this needs to go up. But I am always afraid that I will introduce a bug by doing it, but I don't think I will. I like the order of these lines to match the order of the sliders. Moving on, I was looking for strength. Yeah, I think I got everything. Let's test. First, I'll leave myself a to-do here because this is where I want to do the sharing of gain between plugin instances to determine the video winner. Anyway, I'll just leave this to do here because this is the place where we want to write code. That's what we determined before. Let's review the changes and see if I broke something by introducing this video global variable or group-wise variable. Okay, I kind of like the way that this reads. It makes some sense to me. First, if the global namespace used to communicate the global variables is not initialized, then initialize it. When an instance is created, initialize it. When you change the slider, sync with the global parameter. And when the global parameters have been changed to sync with this instance. That makes sense to me. But we know there is a problem with saving and reopening the project, and saving, closing the project and reopening it will lose the settings. So we'll need to fix that at some point. That's what we learned yesterday. Anyway, let's put the Automixer in the tracks again, and I expect this video variable to be synced across instances, and it is synced across instances, but if you are in a different group, then it should not be synced, and it's not. Perfect, that's exactly what I want. And note how when I switch to group 2, then the two instances are no longer interacting, so both of them are always with a gain of 1 because you are not competing with anyone. There is only one microphone in the proverbial room. And Fotis is here. Hello, Fotis. Great to see you here. How are you doing? Looking forward to talk to you and to Silwitz and to Bo and to many other people tomorrow on the C++ Digital Signal Processing Juice study group. If you are into C++, then make sure to tune in tomorrow and join us on the Discord group. The link is in the description. First, you go to the link to my website and from there to Discord, and you can talk to us about this study group and anything else that is happening here on the channel. Anyway, so we need to share the gain. We already have that global parameter. We just need to use it. What is it called? Well, to access it, we'll have to do a line that is similar to this. But we also want to check that we are in video mode, right, to save that work. So if you are not in video mode, and most people will not be, this block will be skipped, and this work will not take any CPU. Great. So instead of looking at the gmem track group, I will be looking at the gmem track gain. And what I want to do in this case is just to store my gain. So I am a plugin instance. I just computed my gain. I write that gain to the global bus. That's simple enough. I will commit it. But of course, that's not all. We also want to determine who is the instance with the most gain. For that, we'll need to see the gains of every other instance, because every other instance will have written their gains because of this line. So let's backtrack a little and find a place where we query all the other instances. It is here that we do that. And this is the place where we go to every other instance and ask, what is your loudness? In this case, what's your RMS? Because I need to know that to compute my own gain. So that's what all of this is about. That's what's happening here on these lines. So I guess right now in the code, there is only one thing that needs to happen, and that is to compute the sum of all the RMSs from all the tracks. But now there will be potentially multiple things to happen. So I guess I'm going to change the way that this code is written so that if the group is the group of this other instance I am querying, if its group is the same as our group, then run a whole block of code. This block of code naturally will start with this that was already there. Oh, I actually want this part of the condition to be there as well. This solves a problem that occurs when you delete an Automixer instance or when you bypass an Automixer instance. That instance is no longer in the pool. It shouldn't be considered when talking about the sum of all RMSs. It should not be considered when looking at the gains for the video processor and whatnot. So let's let's backtrack on the changes I introduced because I am not happy with what I wrote. Yeah, so these two conditions are necessary for me to even consider this track in the computation. So I'll just put parentheses here like so. I guess this is better. So in other words, if I should consider this track at all, then do this, but also do that, do some other thing that I'm about to start. And that is gains, gain all tracks, let's say. I will start with 0 because gain is a number between 0 and 1. And I will want to see the maximum of the gains between all the tracks. So I will say something like this and that. And I only want to run this line if I am in video mode. Again, this video situation, I'm trying to prevent work. I may be doing more harm than good because I am introducing lots of conditionals, even conditionals in loops. And conditionals are not free because the processor needs to do some, what is it called? Some predictive branching. I forget the name of the thing that the processor does, but it will try to run speculative branching. I think that's the name. It will try to run both branches of the possible futures. The possible future in which the video is true, the possible future in which the video is false. And it will need to reconcile these computations with what really happened. All of this takes a lot of time and it has to do with how the CPU pipelines stuff, whatever. The point is, branching is not free. I'm introducing lots of branches to do this, so perhaps it's not the best idea. But at the very least, it does make the code stand out more. When you see this video question mark, it means, okay, this is code that I had to add specifically for the video stuff. So it may not be saving CPU, but at least it is marking the code with all the places we are changing to add the video feature, which I think is kind of useful from the perspective of someone reading the code, because it will communicate all these extra things that happen to make the video feature. I think that may be useful for future readers. We'll see. It may actually be bad. And IDGQD stuff, IDGQD stuff is when Fotis and stuff and IDGQD sound meet. So IDGQD sound, hello Arya, great to see you here. Did you consider making the video on a separate JSFX? That's a good point. This separate JSFX, what would it need to do? It would need to access the same namespace as all the other plugins, and that's relatively straightforward. You just have to do this option and then it will have access to the global namespace. So this would need to happen. Hang on, what would need to happen? This would need to happen on the regular Automixer because you will need to write this to global memory. But this is something that in theory could be done on a separate plugin. I don't think it's advantageous though. I think that it's better to have a single plugin to handle all of this. I think it will be simpler for people who want to use it. They will just drop Automixers on each track. And I also think it will be better for if in the future we find a way of translating this whole concept to C++, which in theory should be done, should be possible. If we are able to do that, then it really is advantageous to have a single plugin because this whole concept of gmem is implemented in C++. Well, there are several ways of doing it, but the way that we are going to try and do it is to just use some global variables in C++. Or something that amounts to global variables. So if you have different plugin instances, they live in separate namespaces in memory, and then communicating between them becomes a lot harder. So I'm prototyping this whole thing in JSFX. I plan on translating to C++, so doing everything in a single plugin is better for that, I think. I think it will be better for that. And all right. Let's see what else you have to say. Gmem will likely be slowish, so I would agree with that branching on video will probably save some CPU. Oh, good. You have, for people who don't know, Tail has a lot more experience when it comes to performance. And if you are saying that, Tail, I think I'm on the right track. Thanks. Is JSFX precompiled or JITed to machine code or just interpreted? Okay, for people who don't know, JIT means, it stands for just-in-time compilation. So this is when you turn some representation of your program, maybe the textual representation, but most commonly an intermediary representation. You turn that into optimized machine code, the thing that your CPU actually sees, just in time when your program is running. You start your program with the text, you start your program with the bytecode or whatever other representation of your program there is, and you compile that while you're running the program or just before you run the program. And the reason why some people like doing that is that you can compile to that machine. You know how much memory it has, you know the kind of processor, you know even the load on the machine at that point. So you can also instrument the code to find the places where the code is spending most of its time, so you can optimize that section more aggressively. And that's why just-in-time compilation is done by, for instance, the Java virtual machine, even the JavaScript engine that is running in every browser. All of these do just-in-time compilation. And then the question is JSFX precompiled or is it just-in-time compiled? Or is it just interpreted? So interpreting is not compiling the code into machine code. It is just you have a program that is capable of reading this and running it without translating it first. So to answer the question, as far as I understand, JSFX is compiled when you load the plugin. So it is when you do this, it has compiled my JSFX right now. And probably if you close and reopen the plugin, it will have some sort of cache to not have to recompile stuff all the time. So is it precompiled or is it just in time compiled? I would say it's precompiled, but it's precompiled when you load, which is not exactly the same as just in time compilation because you don't go into the JSFX, instrument it, find the loops that are hottest and optimize them more aggressively. All of those things that like the Java virtual machine does. JSFX doesn't do any of that. It just compiles once when the plugin is loaded. And as far as I understand, it is compiled. I'm pretty confident on this information. First, because over here we can see some information about the compilation. So you see, for instance, the slider section of the code, you can see the amount, I guess it's the number of tokens perhaps, and then the amount of tokens in the source. So like variables and equal signs and that kind of thing. And then the spaces are ignored. So this would be the source, and then the code is the machine code that was compiled. So this is information about maybe the number of operations that happen in that section of code. So there is that. There is also the issue that we found some bugs in JSFX, and then they were specific to ARM. So pretty sure that it is compiled. It's not just interpreted. I think that trying to run this interpreted instead of pre-compiling is just not doable. I think it would be too slow because we are trying to process audio in real time. It's 48,000 times a second. There's no way you can do this in a performant manner with an interpreted language. And JSFX are fairly performant. It's not super optimized, but it is fairly okay. Tormi is asking, I see a look ahead. How can look ahead when the signal is in real time? Did I miss something? Is it capable of watching in the future? Yes. So you can watch our I cannot say this with a straight face. No, we are not looking into the future, of course. We are adding the look ahead for people who want to do that are accepting some latency. So we even report the latency here to REAPER naturally. And it's not unheard of, even on live broadcasts, to introduce a latency. Maybe because you want to prevent things from going to air. If someone is saying curse words in a place where you are not allowed to, and if there is some, maybe even the editing thing that I was talking about, you want to catch someone's reaction, so you want to be able to cut to a camera after the fact, introduce some latency there. And I guess even something like what I am doing right now, my camera has some latency, 200 milliseconds specifically. So I add latency to the whole stream, right? Because of that, I add latency to my microphone. I add latency to the thing you see on the screen so that everything syncs with my lips. Doesn't always work though. Anyway, let's try to at least do what I promised we would. So right now we have this gain all tracks. That is the maximum of the gains of all tracks except for our track. Right, yeah. That's an issue right then and there. When we are computing the sum of all the RMSs, of all the loudnesses, of all the tracks, we have already written our own loudness to the global namespace. We have done so right here. So we can simply add this up because it's already there. But the gain of our own track is not there yet because we haven't computed it. And we cannot have computed it because this line is necessary for us to compute the gain. So I can see two possible solutions. The first is to break this loop apart into two loops. Instead of doing all of the computation you can do in one pass over the tracks, you could separate this in two passes. And then down here, we would do another pass. But that is probably going to be painfully slow because you're looping over all the tracks and you're checking that the track is valid, so to speak. So it's a lot of work to repeat all of this. What if instead we are a bit more elegant and we check that it's not ourselves? So we will say something like track is not track current where track current is our own ID here. This way, we are skipping over ourselves when doing this traversal. In this way, the gain of all tracks is the gain of all tracks except for ourselves. And this is crucial because we don't want the previous gain from our track to affect the current reading. For all intents and purposes, the GMAM track gain of ourselves is stale, it's obsolete. We shouldn't be taking that in account. So that's what this does. It prevents us from looking at our own track. Great, but that also means that this sum is now not taking in account our own RMS, which is incorrect. So we should be starting with, instead of 0, starting with our own RMS. And that seems correct. Now, this is a pretty invasive change to the code. I think that all my reasoning is correct, but let's run the Automixer again real quick just to double check. What I expect to see is the gain being allocated to my microphone as I speak, just like that. So it seems to be working all right. Let's commit this change. And then let's go down again here. So in this place, we are writing our own gain into the global namespace, and we also have to determine if we are the winner. So this is what I will do for now. I will do something like winner is equal to, if my gain is greater than the gain of all tracks, I am the winner. Let's see this in action. I will just inspect the two instances because I want to see their variables in real time. Let's filter for winner. And none of them are winners because we are not running in video mode. Now we are running in video mode. So this is not good. First of all, they are both 1, and second, they never go to 0. Oh well. What is the gain? The gain looks okay. The gain of all tracks is not okay. That's because this variable is wrong. It shouldn't be the track, it should be the track current. Let's look at, hang on, I'll put 2 instances. I will enable video. And I will open the debugger again for both instances. Let's filter for the winner. And this is what I wanted to see. So when I start speaking, you can see that this track becomes the winner. And when I stopped speaking, the other track became the winner because of the sine wave that is running through from the tone generator. Great. So we are able to determine the instant, I guess the instantaneous winner. So I did what I promised. We are able to determine who is the winner right now. But if we were to change cameras just based on this, it would be hectic. It would be switching back and forth between cameras too fast. But it's a start. The next step is to smooth out this winner over time. Effectively a low-pass filter, kind of, but we'll try to be smart and implement some heuristics to try and make this as human as possible. Yeah, sure thing. Couldn't you simply subtract your own gain after the loop? The suggestion here is, instead of checking this condition in a loop, which is expensive, couldn't you just add your own gain here? And you know that it is stale, so you just go and subtract that after the fact. Yes, you can do that. Well, not really. Hang on. This is not addition. This is the maximum. Oh, okay. Perhaps the suggestion is that you would just check this. I think I see what you say. What you're saying. We could add. For instance, for this variable, we could add the same value twice, maybe our own RMS, add it twice and then subtract it later. But in this case, we are taking the maximum, which is destructive. We cannot take the maximum of two things and then find the lesser thing. It's gone. We lost that information. So in this case, it doesn't really work. And I don't think that I don't see the advantage of doing it that way. I think it's better to just check that we are not looking at ourselves and then adapt the code around that. So now we know that all tracks here really means all tracks, but here it means all tracks except ourselves. I'll call this all other tracks. So it's not all tracks, it's just other tracks. And it's not really the gain of all other tracks, it is the maximum. And this is how you end up with long ass names. Anyway, I just renamed stuff. I didn't break anything, did I? Hope not. No, you're right, you can't. Okay. Fair enough. All right, I still have some extra time and I started late, so let's implement something else that I promised I would do yesterday and then forgot about it, but hey, I'm gonna get to it now. When you are in different groups, I will color the waveform differently, because I imagine people using this in the mixer here with the mixer control panel windows like that, and then you will see the different groups with different colors of waveform. Simple enough, right? It's just a conditional for picking the color. So let's go ahead and do that based on the group. Fun stuff. I think I will leave the red for the gain for now. But the gray warm, we will want to change. And we have a bunch of groups. We have 32 groups. We don't have 32 colors. So it will repeat after a while. How many colors do we have? I have a design system in the library. Exactly for this kind of thing, so that I don't have to start picking colors right now. I can just go in the library and get some. So we already have the gray. And perhaps for funsies, let's not use gray. Let's just use colors. So we have that. I'm putting this in a new buffer so that I can do things like, what do I want to do? Can I do something like this? No. I guess I will just have to manually go to the start of each color. I am pretty sure that I have a list of colors somewhere. but I don't know where, so it's easier for me to just go ahead and grab all of them again. Like that. Okay, these are the different colors. And I will be smart and leave this for myself for the future. Except that, of course, I will forget that I have done that and I will go through the process again. But anyway, here are the different colors. And for this application, I don't think I want to use all of these because they are too close to one another. So if group 1 is red and group 2 is orange, it may be difficult to see the difference. Especially if you're doing like live mixing and you have this in front of a computer in an event, and then the brightness of the display isn't great. So you want the colors to be very different. So I guess what I can do is just skip every other color. They were ordered in, you probably noticed, they are ordered like the rainbow. They are ordered by hue. So if I just skip every other color, they should be more distinct now. Maybe not by a whole lot. But we'll see. And how many colors do we have? We have 9. How about we cut the last one, because red and rose may be too similar. So if we cut the last one, we end up with 8 colors, which is a power of 2, and that's good. It doesn't matter in the slightest, but yeah, it's a good number. So we will go to these two situations here, and we'll check if the group modulo 8, because we have 8 colors, is equal to 0, I'm trying to do this with the least amount of typing. Let's see how well I do on this. Oops, forgot an underscore, or forgot a dot. And this is one of the few times when I think maybe if I was still using Emacs or Vim, I could do a little macro right now. But hey, I have the whole rest of my life ahead of me without using Emacs and Vim. And if you don't know what I'm talking about, then don't worry about it. You don't need to know. You're not losing too much. I think I did it. Let's try it out. So in case you are wondering what is this doing, it's making sure that the group, which is a number that goes between 0 and 31, is now a number that goes between 0 and 7. That's what this is doing. It's taking the remainder of the division between the group, which is a number between 0 and 31, and 8. And it's checking if it's 0, 1, 2, 3, and so on. Remember about 7 months ago when I was thinking about making colors values, and in this case they're not values? This is the place where it could come in handy that colors were values, because I could have a list of colors. But right now they're not values. Yeah, let's test this. What's the worst that can happen? Okay, the waveform is a bit red. But it may not be the best color for the first group. But anyway, so this is going to be group 1. This is going to be group 2. And the color is very distinct, which I like. I think that even in poor lighting conditions, I think that these colors will be different enough. Great. Perhaps I want to change the 500 to 100. Perhaps I want to change some of the colors. Maybe I don't want to start on the red. Let's work on that for a moment. But first, let's hear what you all have to say. All right, let's do it. Let's switch. I'm not too happy with the red. Let's go through all of them and see one that works better for me. This is sort of similar. This is okay. That I quite like. Probably my favorite so far. Not too good. And then we are going to wrap back again to red. Yeah, I think that my favorite is 6. So it means that my favorite is, in this case, 5 here, because I'm starting with 0. This is super slow, by the way. If you are the way to make this fast is to make an array of these colors and index with the group into the array, or I guess index with the result of this into the array. That's the fastest way of doing it, I think. The second fastest way of doing it, or maybe the fastest, these two are a bit hazy. I know that this one is the worst, but the second, perhaps first best way of doing this is with a binary search. So you would look at the result of this and check, is it greater than 4 or is it less than 4? And then you, instead of having, in the worst case, 8 comparisons, you would have 1, or you would have 3, because that's the logarithm of 8 base 2. Then another thing I could be doing is not compute the group modulo 8 every time, because I'm repeating this operation at worst 8 times. But you know what? I'm not going to. Just going to leave it as it is. Let's play around with the 500 to see if another number makes more sense. Let's try to go darker. Okay, hang on. This is not the color I wanted. Am I off by 1? I think that this was the color I wanted. Let's redo this exercise. And how about, oh, hang on, I changed the color of the background. This 600 is the background. The background is the input. And that's actually okay. Yeah, I quite like that. But perhaps this 200 could be a bit stronger. That's the foreground. And that was the one I was thinking about. If it is 300, I think it will work better. That's still not the color I wanted. What the heck? I need to go in the other direction? This is embarrassing. Okay, that's the color I wanted. Now we have it. And yeah, the this looks fine. I like it. And I think that this darker background color is, or I guess lighter background color, it is making this pop out better. So I'm happy. And it looks very fine. Looks very fine, very nice when it is here. Awesome. Let's see what more you have to say. For what it's worth, modulo is probably not hyper efficient, so caching it might be a good idea. And if you are sticking with 8, then you could also do N7 instead. This is a bitwise operation to only keep the 7 rightmost bits, which amounts to the same. You are right. You know, I will do it. It's just gonna let this be super slow, but whatever. Let's do it. But I will not do it the bit mask way, because it is too obscure. I happen to have 8 colors, so I could be faster, but you know, let's make it readable. So I'll call this the JSFX group color. JSFX is a prefix I need on every JSFX variable because I don't want to accidentally clash my variables with other blocks. And this will be that. And I guess this is the color index, really. And it should look the same. And it looks okay. And if I switch to other groups, it's still looking fine. Okay. There you go. So now I promised that I would do this yesterday. I forgot. Now I did it. I remembered. And with that, I think it's time to wrap up. So tomorrow we'll be meeting the C++ digital signal processing JUICE study group will be meeting. So tune in for that. Fotis will be giving his update. Bo will be giving his update. We have been having iPlug issues that we'll talk about, and probably Seawitz will share his progress as well. It will be a lot of fun. Then on Thursday, I may get back to this. I am not sure what I am going to do next. It's probably going to be to continue this video stuff. So right now we have the winner. It's time to smooth out this winner. So I think that that's what I'm going to do. But tune in on Thursday to find out. So with that, thank you Fotis, Theo, Thormy, Mage, IDDQD or Aria, and Bo. Did I already say Bo? No. So thank you all for joining me on the chat. Thank you to everyone else who is watching this. Thank you for supporting the channel on PayPal and Patreon and whatnot. And I will see you tomorrow. Have a good one. Bye. I already know that the keyboard shortcut is not going to work, so I'll say this again. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.